Today we are starting a new unit, and we are going to be talking about the law of sines today. So far, our study of trig, we have only been using right triangles. Everything that we have done so far has been based off of right triangles. In this unit, we're going to be talking about using what we know about trig to solve oblique triangles. So oblique triangles are triangles that have no right angles. Okay, so first of all, let's talk about what it means to solve a triangle. To solve a triangle, that means we are finding all sides and all angles. Okay, so when we say to solve a triangle, that's what we mean, right? In order to do this, we need to know the measure of at least one side, and you need to know the measures of you need to know two other measures, either two sides, two angles, or one side and one angle. And that's true regardless of if it's a right triangle or not. If you know it has a right angle, then you know one of the angles. Okay, so we're going to be using two laws to do this. We have the law of sines and the law of cosines, and they are used depending on what you are given. You'll know which one to use. All right, so today we're talking about law of sines. All right, so for the law of sines, what the law of sines says is it talks about ratios. The ratio of the sine of any angle to its opposite side is the same as the sine of any other angle, the ratio of the sine of any other angle to its opposite side. So whether it's sine A to side B is equal to sine A over side B, or sine of angle C over its opposite side, little c. All right, so we're talking about ratios here. Law of sines, so sine of angle A, the ratio of sine of angle A to its opposite side must be the same as the sine of angle B to its opposite side, which is the same as the sine of angle C to its opposite side. So we set up a little proportion with these. Law of sines is easy because it involves proportions. And since it does involve proportions, we can flip each of these and call it side A. The ratio of side A to the sine of its opposite angle is the same as B over sine B, sine of angle B, and that's the same as side C, to sine of angle C. So you can flip those. And I use whichever one I am trying to find. So for example, in number 1 here, we are looking for side C. So since I'm looking for a side, I'm going to be using this version. If I'm looking for an angle, I'm going to be using this angle. It just involves one fewer steps in the solving process when you're working it out. Okay, when to use law of sines? You use law of sines when you are given a pair. So we need a pair. We need an angle and its opposite side. So in number 1 here, we are given side A and angle A. So we are given a pair. When you have a pair, you can use law of sines. Okay? All right, since I'm looking for side C, I'm going to set up C over sine of angle C must equal A to sine of angle A. Must be true. That's the law of sines. So let's fill in our numbers. We're looking for C over sine of 65 degrees, and that's equal to 12 over sine of 58 degrees. So as you see, we have degrees, and we haven't had degrees for a while. So when we're using our calculator, and we will be using our calculator for these, when you're using your calculator, make sure that you go change your mode setting, change mode to degree mode. Okay, and then you'll be using the right mode to find out these answers. Okay, so to solve this, when I ask in class, how do you solve this? A lot of kids say cross multiply, and that's very true. We are going to cross multiply, except I really don't want to cross the sine of 58 degrees because I want to get c by itself. So I don't want to bring something over with it when it's already on the other side. So I am going to cross multiply, but only the denominator here, only the sine of 65 degrees. So c will equal 12 times sine of 65 degrees divided by sine of 58 degrees. You don't have to write the degree symbol all the time. I like to denote that I like to reinforce the fact that we are in degrees here. When you're at this point, time to go to your calculator, and we're going to type that in. So go to your home screen, and we're typing in 12 sine of 65 degrees. Notice that your calculator automatically gives you this parentheses, so you have to close that parentheses if you're going to be doing anything else in the problem. If it's the very, very end, then it's not required to close that parentheses, but this is not the very end, so we are required to close that on the 65. Divided by sine of 58. Now we are at the very end, so it's not required to close that parentheses, but I do like to do it. So we get 12.824, and we always give answers accurate to 3 places after the decimal point unless you're told otherwise. This last place can be rounded if the 4th place is a 5 or larger. Number 2. So in this one, again, I am given a pair. I'm given angle B and side B. So I know I can use law of sines. Okay? I'm looking for angle A. And I'm given side A. So this is a basic law of sines. So since I'm looking for the angle this time, I'm going to be using this version of our law of sines because I'm looking for the angle. So I'm going to set up sine of A divided by its opposite side, A, is equal to sine of B over its opposite side, 8.4. I'm going to fill in my numbers. So I have sine of A over 6.2 is equal to sine of 105 degrees divided by 8.4. Okay, once again, I'm going to cross multiply, but only the 6.2, and I get sine of angle A is 6.2 sine of 105 degrees divided by 8.4. At this point, we want to get A by itself. We still don't have A by itself. So what do we do on both sides to get A by itself? Well, we sine inverse both sides. We inverse sine both sides, and that gets angle A by itself. Okay. So angle A will be sine inverse of 6.2 sine of 105 degrees divided by 8.4. Okay. I like to write into my calculator the entire expression. I tend to make fewer mistakes that way, and students tend to make fewer mistakes that way. So into our calculator we go, and we're going to have inverse sine. Inverse sine is in blue above the sine key, so do second sine, and it'll pull up inverse sine. And now we have 6.2 sine of 105 close the parentheses around the 105 because we're not done yet, divided by 8.4, close parentheses around the sine inverse, and this will give you your angle A, in degrees. And once again, I give 3 places after the decimal point unless I'm told otherwise. Okay, number 3. In number 3, we are given angle B and side B, so I know I can use the law of sines. Okay, I am looking for side C. Well, if I'm looking for side C, I need angle C, correct? I'm not given angle C, I'm given angle A instead. So, since I'm given angle A, but I'm looking for side C, I need a way to find angle C. We're going to use the fact, I need to plug in my computer here, hang on. Get the right cord. Okay. Alrighty. Sorry about that. Okay. We are going to use the fact that that the angles of a triangle always add to 180 degrees. So to get angle C, to get the measure of angle C, we will take that 180 degrees and subtract the other 2 angles, 96 and 37. So the measure of angle C is 180 minus 96 minus 37, 47 degrees. Okay, so now we can set up our proportion. Angle C to sine of, not angle C, side C to sine of angle C must be equal to side B over sine of that 96 degrees. So there's our proportion. We're going to cross multiply. So C will equal 15 sine of 47 degrees divided by sine of 96 degrees. So 15 sine 47 divided by sine 96. And we get 11.03. I'm going to round that 0 to a 1 because the next number is a 5 or larger. And that's how we do that one. Okay. Next example. In this example, we want to find x, and we're given this figure. So we want to find x, and x is the angle, right? So to find x, I'm thinking I need the opposite side, and I don't have the opposite side. Instead, I have the other 2 sides. So we want to get either the opposite side, or we want to find x using the fact that these angles add to 180. So since I cannot find x using law of sines because I don't have the opposite side, I will find another angle using law of sines. So I'm going to find this angle. I'm going to call that something. Maybe I'll call that y. I'm going to call that something because I have its opposite side. And then I do have a pair. We have to have a pair. Okay, so I'm going to set up sine of that angle y over its opposite side 6 must equal sine of 97 degrees divided by its opposite side 7. Cross multiply. Sine of angle y is 6 sine of 97 divided by 7. So y is inverse sine of 6 sine of 97 degrees over 7. To our calculator we go. inverse sine 6 sine of 97, close the parentheses around the 97, divided by 7, and we get 58.29375 dot dot dot. I'm not going to round it because that's not my final answer. Okay? My final answer, I'm looking for x, so don't round until you get to your very final answer. Okay, first to get x, we're going to take 180 degrees, subtract the 97, and then subtract what we just found for angle y. So 180 minus 97 minus, and to get up there to that number quickly, you can scroll up. On most calculators, you can scroll up and grab it, bring it down, push enter to bring it down, and then hit enter again. So x is 24.706 degrees. Okay. Another way to get that, to get a previous answer, is to go to second and then go to that negative sign. It'll get you your answer, the previous answer. Okay. Number 5, let's find w. So I'm looking over here at w, and I'm asking myself, do I have its opposite angle? Do I have its opposite angle? I don't. I'm not given it. But in this one, I'm given a quick way to get that opposite angle. So I'm going to say that this opposite angle is 180 minus 31 minus 98. And that's 51 degrees, and that's that angle right there. Yeah? So now I can set up a proportion. And by the way, I am given an angle and its opposite side, so I know I can use law of sines. That's the only way you can use law of sines, is if you're given an angle and its opposite side. If you're not given that, then you have to go and use law of cosines, which we're going to learn next. So w is to the sine of its opposite angle, as that 14.8 is to the sine of 31 degrees. So w is 14.8 sine of 51 degrees over sine of 31 degrees. 14.8 sine of 51, close the parentheses around the 51, divided by sine of 31. 22.33, and I'm going to round that 1 to a 2 because that next digit is an 8. Okay? Alright, number 6. In this one we want to solve the entire triangle, so we want to get all sides, all angles. Alright, so we are given angle A is 52 degrees and angle B is 65 degrees. And remember, to solve a triangle, you have to be given 3 things, including one side. And we are given that side A is 8.5. Since we're given a pair, I know I can use law of sines here. Okay? Now, I see a couple of different things I can do first. What I cannot do first is find side C, but I could find side B using law of sines, or I could find angle C using the fact that these 3 add to 180 degrees. I think I'm just going to use law of sines first to find B. So B is to the sine of its opposite angle, as 8.5 is to the sine of its opposite angle. Cross multiply, and B is 8.5 sine of 65 divided by sine of 52. So B is B is 8.427, and we have found side B. Okay. All right, to find angle C, we are going to add those together. Subtract from 180, so 180 minus 52 minus 65 will give us angle C. So 180 minus 52 minus 65, 63 degrees. Okay, I guess I can write that here. All right, and then lastly, to find side C here. To find side C, I'm going to set up law of sines. C is to the sine of its opposite angle, what we just found, as, okay, I definitely want to go here and use the 8.5. Okay, otherwise I could use B, but make sure if you use B, make sure you use the entire thing and not your rounded version. I would always go and use a number that I'm given that's exact before I use one that I have found previously, if I can avoid it. Sometimes you cannot avoid it, but if we can avoid it, I would do that. So I'm going to use the 8.5 and sine of angle A. So C will be 8.5 sine of 63 degrees divided by sine of 52 degrees. And get that in, and we get 9.61, and once again I'm going to round that 0 to the next higher number because this is a 5 or larger, so 9.611. Whoops. And we solved the whole triangle. One last example on law of sines. This time we're given that angle C is 93 degrees and side C is 9. I'm given a pair, so I can use law of sines. And side A is 8. Okay, so I think our only option here, since we're not given either angle B or side B, is to find angle A first. So I'm going to find angle A using the law of sines. Sine of angle A over its opposite side 8 must equal sine of 93 degrees over its opposite side 9. Cross multiply. Sine of angle A is 8 sine 93 degrees over 9. And at this point, I'm not going to write that I'm using inverse sine. I'm just going to go and use inverse sine. So we'll get to where we can see everything. All right, so inverse sine of this expression, 8 sine of 93 degrees divided by 9. And that gave us angle A. So 62.5819957, and that goes on and on. Okay? That's the unrounded version. What I write here will be my rounded version, 62.582. But I need to remember that I did round that. So to get angle B, I can take 180 minus 93 minus angle A, and that will get me my angle B. So 180 minus 93 minus this value that we just found, and that will give me 24.418, and again, that's rounded, but if I need to use it, and I do need to use it, I'm going to use the unrounded version. Okay? So to get side B, I need to set up law of sines. Okay? So I am going to use, I have to use angle B this time. So just know that I am going to be putting in the entire unrounded number there. Okay? And then I'm going to set it equal to, not this one, but I'm going to set it equal to this one because I have the exact angle there. So this is equal to 9 over sine of 93 degrees. Cross multiply there, and B will be, I'm going to do this right here, B will be 9 sine of that what we just found. I'm going to scroll up there, grab that, close parentheses, divided by sine of 93 degrees. So B is 3.726. And that is law of sines. So we can use law of sines again when we're given any angle and its opposite side. We can find anything else using law of sines.